this video. This is the second half of the notes for section 9.2, angles and angle measure. So, just to kind of review from yesterday, make this bigger. Reviewing from yesterday, we have a coordinate plane, and our angles always start with your initial side, is what it's called, in the positive x-axis. So this is your initial side. Do you remember what the other one was called? The terminal side, okay? So let's say your terminal side is over here in the second quadrant, right? They're 1, 2, 3, 4, okay? So there's my angle, right? The angle is measured this way with a positive angle, or you can measure him all the way around this direction, and that angle would be negative. And then we talked about spinning around one more time. Do you remember what those were called? When it looks exactly the same, but it's one more rotation around. Co-terminal. Okay, so let's talk about how many degrees each one of these is. So let's say I have an angle that looks like this. How many degrees is that? 90? What about if I have a straight angle across this way? 180 degrees. If I'm going this direction all the way around, that's 270, and all the way around would be 360. Okay, now 270 we talked about yesterday about how that is also negative 90 degrees, right? Okay, so keeping that in mind, 90, 180, 270, and 360 on that coordinate plane. Okay, now, I told you guys when we were doing SOHCAHTOA in section 9.1 that on your calculator might be in the wrong setting if you get the wrong answer, but typed it in correctly, because you might be in radians instead of in degrees. Do you remember me saying that? Okay. So there's a setting on your calculator called radians, and you're going to learn what a radian is here right now. Okay, so here is my coordinate plane, and we said 90, 180, 270, and 70, and 360. That's how many degrees that is, okay? All the way around, it kind of makes a circle, all right? And let's say that this circle has a unit measure of 1, okay? So like the radius of that circle is 1. Okay, and now let's talk about the circumference of a circle. Do you remember how to find circumference? Circumference of a circle, 2 pi r. You remember that? Maybe not. You haven't had geometry yet, so whatever. Circumference is 2 pi r, but if my radius is 1, what's the circumference all the way around the circle? 2 times pi times 1. What? Yeah? So, that tells me that the distance all the way around here is 2 pi, right? 2 pi all the way around. So, in a way, 360 degrees is the same thing as 2 pi, because that's the distance, right? The number of degrees is 360 all the way around, but that in terms of radians is 2 pi, right? Okay. What would 180 degrees be? If I'm just going part of the circle, what? So 360 degrees is 2 pi. What would just be half of that be? 1 pi, right? 1 pi is the number of radians that would be, just from here to here. That's 1 pi, okay? 90 degrees would be half of a pi. They will write it as pi over 2. That's what 90 degrees is, okay? Now, what is 270 degrees? If this is pi over 2, or half of a pi, this is a pi, this is 2 full pies. 1.5 pi, which they'll write as 3 pi over 2, okay? Those are the equivalent markings in radians. So it's kind of like one of them is measuring the degrees, and the other one is like measuring the distance, right? These are the degrees, and these are like the distances that will be. 270 is 3 pi over 2. 3 pi over 2, that's what those are. Okay, now, there's a way to convert things from radians to degrees and vice versa, and we're going to do that in part A and B in the next example. And the conversion that we use is this one. 180 degrees is equal to 1 pi. Really, 360 is the same thing as 2 pi, but reduced, 180 is equivalent to equivalent to 1 pi. Okay? So when I'm trying to convert something from radians to degrees or degrees to radians, like this one and this one, I'm either going to use pi over 180 or 180 over pi, right? Those two things are equivalent to each other. Pi is the same. Pi is just the distance that 180 is. And 180 is the degrees for the distance of pi. So I'm going to use one of those. When you convert from like feet to inches, do you guys remember doing, have you done in Mr. Moose class, maybe you do like 200 inches. You guys haven't had Mr. Moose? Yeah, 200 inches, and you're trying to convert that to feet? Yes. You would put the inches on the bottom across from inches, right? And 12 inches is 1 foot. And then you'd cross the inches out, right? That's stoichiometry, right? Okay? So you're doing a similar process here. In part A, you're trying to go from degrees to radians. So I'm going to write that as a fraction, negative 30 degrees over 1. And then if I'm going to multiply by another fraction, what do I want to have here on the bottom? I want to have the 180 on the bottom because I want the degrees from here to cancel with the degrees from here. Kind of like the inches canceled with inches down here. Does that make sense? Yeah? But what is 180 degrees equivalent to? Pi. So in that case, we're going to use pi over 180 as our way to switch to the other one, okay? And then we just reduce. So 30 and 180, I can cross off a 0 on both of them, but how does 3 and 18 reduce? 1 and 6. I'm going to use a different color. 1 and 6. So this is 1 and this is 6, okay? So what I have left, we're not going to convert to a decimal or anything. Negative 1 times pi is just negative pi over 6. And that is the same thing as negative 30 degrees. But negative 30 is the degree, and negative pi over 6 is like the distance that is. Yeah? They should. Like this one, negative pi over 6. You might have like negative 7 pi over 12 or something like that. But you reduce it down to the point where it can't be reduced anymore, and you'll never have a decimal in there. But it will always have something kind of nice in there, yeah, I guess. So this next one, now you're going from radians to degrees. So it's already listed kind of as a fraction. And we want the pi to cancel with a pi down here. Does that make sense? Like the inches and inches cancel. Okay? So that will cancel with that, but that is equivalent to 180, right? Because I want to go from radians to degrees. Okay? So now I'm going to reduce. I've already crossed the pi's out. I'm going to reduce now. So this 2 can cross out with 180. How many times does 2 go into 180? Yeah, I heard somebody say it already. 90? Okay, and then everything else is crossed out but the 5 and the 90, and that makes, what? 450 degrees? So 5 pi over 2 is the same thing as 450 degrees. Okay, so you are only ever using pi over 180 or 180 over pi, and what tells you what you're going to use is which one you're wanting to cross out. So what you have to start with, you want to make sure that that's on the bottom so that it cancels out like inches and feet. Okay? So that's what you want to have happen, all right? And then we have something called a central angle, okay? So yesterday we were dealing with this side right here, which is the initial side, and you guys already talked about the terminal side, right? So we put this one, this example that we started with up here in the second quadrant, and we said this is your angle, right? So if we talk about like this in terms of a circle, if I wrap a circle around here, this is called a central angle, okay? It's a central angle because it's in the center of the circle that I just wrapped around the angle, right? That's a central angle, okay? How big do you think that central angle is approximately? Like if you had to guess, how many degrees is that? 135? Sure, sure. Probably pretty close. 135 degrees, that's exactly in between 90 and 180, right? 135 is exactly between 90 and 180. So that's probably about, yeah, it's maybe a little less than halfway, but that's pretty close. Okay, so 135 degrees, that's what your central angle would be. Okay, so now we're going to do one more thing on the back side, and that is finding an arc length. Okay, what? From the center of the circle to the outside, that's 33 inches. Monster truck tires, those are like almost 3 feet in radius. So that thing's almost 6 feet tall. Like the monster truck tire is almost 6 feet tall to start with. Almost, not quite. Maybe like 5.5 feet or 5 feet tall to start with, okay? How far does a monster truck travel in feet after just 3/4 of a rotation? So it's rotating 3/4 of the way, which means I'm stopping right here. Okay? 3/4 of a rotation. Just that far. So I'm traveling along here. I'm doing just that far. How many degrees is that? 270, right? From here all the way around here, that's 270 degrees, okay? Now, if I find the circumference, that would be the distance from here all the way around one full rotation. Okay, so let's figure that out quick. If we're doing one full rotation, circumference is 2 times pi times r. And what we say our radius was? 33, right? 2 times pi times 33. What is that as a decimal? Go ahead and do that as a decimal. Somebody has their calculator. 2 times pi times 33. What'd you get? You should. You should. 207.34? I think that's probably about right. 35. Okay, 207.35 inches. Okay. Did you find your pi button yet? I'll show you here in just a second. 207.35 inches. Now that would be if I was going all the way around the circle, but I'm only going 3/4 of the way, right? Okay? And 3/4 of the way is 270 degrees. Out of a total of how much? What would be one full rotation? 360, right? So I'm only going 270 degrees of the way, right? So 270 degrees is three-quarters of a circle, right? That's what our angle is, okay? So when you're doing this, you look at the entire circumference first, and then you multiply by just the fraction of the circle that you want, which is only 270 degrees out of the total 360, right? Okay? Now 270 over 360, they've already told us, is 3/4. So I just want to take my ending number and multiply by 3/4, or 270 over 360. Right? That's what that is. So take that 207.35 and multiply by 3/4. And tell me what you get. What's 3/4 of 207? 155.51, and that's in inches. So we've traveled, if that monster truck only goes 155, or only goes 3/4 of a turn, it's traveled 155.51. Now, there's something wrong with our answer and what the question asks. What does the question ask? In feet, right? So how do I convert this to feet? Divide by 12. 12.96 feet. That's crazy. So that monster truck wheel has not even gone one full rotation around, and it's already traveled 13 feet almost. That's like from, I don't know, here to this wall. And that's only 3/4 of a turn. Yeah, of a monster truck. That's not even one full turn of a monster truck tire. There you go. Okay, so the key there is you want to find the entire circumference for the whole circle. Find out what one entire rotation is, and then multiply that by the number of degrees that you're looking at. Because we only want this fraction of the circle, yeah? Only that fraction. Multiply by 270 over 360, and you get the answer. Okay?
Since we have 270, would you be able to just do that instead of 360?
What's that?
Like, since we have 1/2 pi is the 270.
1 1/2 pi. Yes. You're talking about the formula they have up here? Okay, so hold on just a second. So if you know that it's not 270 degrees, if you already know the radians it is, for the formula up here, they make it a little bit easier, and all you have to do is take the radius, which is 33, and you multiply by 3 pi over 2, which is what 270 degrees is. If you do that, you should get the 155.51. And that will get you the answer just a little bit faster. Does that make sense? Because it's already in radians, okay? It's already in radians. So you can either do this formula or you can do this one. This one makes more sense to me, but this one is shorter. Does that make sense? Okay, so either way you want to do it doesn't matter. If you want to convert it to radians already and then plug it into the formula, that is okay. Does that make sense? Okay, there you go.
Do you have a times